This is a October 1843 variant question number 2, and topic is Newton's law. So let's see here. They're pushing this object. Okay, this is not inclined plane. This is simple. Okay, is a you're pushing with a force of 15 newtons. Okay, let me read. A block is pushed along horizontal floor with a magnitude 15 Newton force. Okay, act an angle 20 degrees. So force is acting on angle of 20 degrees. Very clear. The coefficient of friction between the floor is 0.3. So I'm writing here. So coefficient is given by him 0.3. Very clear. Okay. So given the speed of the block is constant. What is constant speed? All of it familiar. Speed is constant because as speed is constant, so you know acceleration 0 because speed is constant, and wherever speed is constant, speed is not changing. I can say from here acceleration is equals to 0 because no change in x speed. Okay, find the mass of block. So I want to find the mass. Let's say mass is m. Let's say mass is m. So now I'm starting this plan. How we can do it? Let's start. Okay, before I start, if you this is a block, I just give an idea to you. If you're pushing from here, okay, your full force, let's say 50 newtons. So full force will apply this direction. But let's say your force direction is changed. Okay, so 50 Newton applied here, so you'll get a 50 Newton force like that. But if your force is applicable on some this angle, okay, so you know what happens? It's two components has. One component is acting this way and one component acting this way. Like you are pushing a table. Imagine this is a table. This is a table you have. Okay, this is a table. You're pushing some table like this, so table will go forward. But if you're pushing the table from some angle with some angle 20 degree, so not full force will push it downward. Some push forward and some push downwards. So I hope so you got the idea. Let me explain in detail with a proper diagram because this diagram is not proper. Okay, come back. So I think so now, inshallah, you will understand. So let's diagram is here. This is a situation we have. A particle is placed here. So let's see here particle. Okay. All right. This particle, and you are pulling from the top here, pushing. Sorry. Okay. An angle with given here, some angle given here, and it is a weight downward acting, and it's normal reaction upward. So now common sense. One more thing is here. So you know what happened? Like whenever you pull, it has two components, this and this. This is a F, this is sorry P, for example. Let's say this theta. So this P cos theta comes and this P sin theta comes. So all of you familiar with this. Okay. But in case you're not pushing, you're not pulling, sorry, you're not pulling. Your direction is opposite. You are pushing. Pushing means like this way, like this way. So do you think component will go this way, up and down, up and it will go right side and upward? No, wrong. So what is the component? Component means same, but direction would be changed. How come? Because you're pushing. So this force will not go this way. This force will act here. This will not go upward. It will go downward. So I hope so. And this P sin theta becomes, it depends upon what the angle you're applying. Angles where, so this P sign comes down and P cos comes here. So same story, what I'm discussing now here, you can see from left side a question, what is the situation? I know some student getting issues, so that is why I'm telling you. So let's start. I change the color. So this pushing, so one push forward and one push. So one push is a forward and one push is inside the table. Okay, inside the surface. Okay, I hope so, got it. And this angle is given by him is 20 degree. And you know when two lines are angle fourth parallel. So if this 20, so this confirm 20. So this 20 comes here. So this 20 must be here. Okay. So I'll draw here 20. And I taught you when angle given, that is cos component. And when angle here not given, so it's sine component. And what is this force? Pushing force? 50 newtons. 50 newtons. So let's start. So this become 50 sine 20. And this become 50 cos 20. Why cos? I said before here angle given. And why this sign? Because angle is not given here. That is why, a way of understanding. Okay. All right. So common sense, you're pushing some object right side. So for example, you're pushing this way. So where is the friction? Common sense backward. So I will make one extra force here. There's a frictional force acting here. Okay, because it is against a motion, or because it is moving with a constant speed. So that is why. So let's start now. So this is R upward, and weight component. What is the mass? Mass is a 10, and into 10 give you 10 m weight component. Okay, according to situation, you have to look carefully. Okay, horizontal, not a I will discuss later. Let's talk about a vertical means upward R, downwards 50 sine 20 and 10 m. So we have two forces acting vertically force. Okay, I'm writing here vertically. So vertically we have how many forces? Let's start. Upward forces equal to downward forces. So R is equals to 50 sine 20 and plus 10 m. I repeat my words. This R is upward, arrow upwards. This arrow downwards, this arrow downwards. Don't involve this arrow or this arrow, because I talk about upward and downward forces. So I will keep it alone here. And now I talk about net force equal to MA. Now I'm talking about horizontally. Net force equal to MA. So let's talk about system is moving where? Look, let me show motion. Motion is this way. Well, how you know, sir? Because when you're pushing forward, so naturally particle is moving this way, right? Left side, okay? And it is constant speed, you know. Okay, let's start. So I will start my situation, my force from here. 50 cos 20, left side, right side of friction. So let's start. So I can say here clearly. So 50 cos 20 minus friction equal to MA, but A is 0, con. Okay, 50 cos 20 and friction formula is mu R, all of you know, equal to 0. Okay, 50 cos 20. Okay, mu R I take on the other end, mu R positive. 50 cos, sorry, 50, not 5. 50 cos 20. Mu value is given by him 0.3. I put it here 0.3. And R value in the bracket, whole will come here. So there's a 50 sine 20 and plus 10m. 10m, I repeat, 10m. Okay, now 50 cos 20. This 0.3 come on left side divide. I get 50 cos 20 plus 10m. Now this whole thing will come and subtract from here. I think I will not now let's just 0.3 minus 50 cos 20. After getting this, I will divide by this 10. So I'm doing direct now. I will not waste further time. So let me check. 50 times 2 cos 20 and divided by 0.3. And after that, negative 50 times 2 cos 20. So I think, let me check once again. I did mistake here. Sorry, this is a sign. This is not a cos. This is a sign. That is why I thought why that they are same components. So 50 sine here. We have a sign here. So I think this is okay now. And I should write here sine and 20. Rest is okay, alhamdulillah. And this is coming divided by 10. After divided by 10, it is coming, mass is coming here 13.95, 13.9514. Approximately, after rounding, it becomes 14 kilograms. So alhamdulillah, I think idea is very, very clear.